Hello, everyone. Welcome to this talk on conversational AI trends and challenges. I'm Dinesh, and I belong to the VLSA special interest group. And we have several faculty here, Neelam, Vishwanath, Professor Ram, Professor Srinath, Professor Srinivas Raghavan, and so on. And our special interest group, Vision, Language, and Speech Analytics, provides a fantastic ecosystem for research scholars to flourish. And we would urge you to look at positions such as research associates or MS and PhD opportunities with the group, and you will have a fulfilling experience. In terms of areas that we work, we have several areas, including conversational AI and medical AI, apart from, say, a few fundamental AI paradigms, which are different from the current ones, which are also interests of the group. Okay. So this is about the VLSA group. And now to our topic of the day, which is on conversational AI, right? And I've also put the additional word, which is multimodal. We'll explain how multimodal is important, right? All of us know what is a chatbot, right? Where you have a text input and a text output, right? And we see this in websites where you have, say, bots which pop up and maybe ask you something in terms of text, and then you type in something, or maybe you can even do a speech input and you get a speech output. All right, so this has become quite common, right? But then if you think about it from the point of view of how far are we from an experience which is like human conversation, right? So maybe can we have a conversation with the agent or avatar, which is almost like a human conversation, right? From that point of view, we're still far away, right? And there are, but then there have been attempts to move in that direction, right? And that is what we will talk about, right? When we refer to multimodal conversational AI. Right? And we have distinctly, let's say, three main components, right? So one component referred to as multimodal analysis, where you're looking at a user, looking at what they are speaking, right? Using a microphone and a camera, and you're inferring what they are speaking, understanding what they are speaking, right? Apart from even maybe looking at their expressions, their engagement level, and so on, right? And you would like to fuse all this information in order to understand the user better, right? And then you would also like to say compose a response, right? Maybe the user had said something, you would like to respond in a certain way. Maybe you also want to maybe consider the fact that maybe they are angry, right? And if they are angry, maybe you would like to compose your response suitably, right? So that is where really the multimodal understanding of the user comes into picture, right? And then finally you have this component which is denoted as fission or synthesis, right? Where you would like to synthesize. Suppose you decide what to speak, you have to say it in a certain way, right? Say you want to say a particular response in an angry way, or in a very sad way, for example, right? And so on. And also you have to have the gestures on the avatar as well, right? So you see there is a multitude of technologies that go into making this multimodal conversational AI going, right? There is speech, both analysis and synthesis, right? Speech recognition, speech synthesis, as well as say in dialogue, you have to understand what the user is saying, as well as you have to generate text, right? You also have to use vision capabilities to understand the user in terms of, say, emotional and engagement state. Maybe you might want to recognize the user, right? And finally, from a graphics point of view, you have to begin with maybe create an avatar and also generate behavior on the avatar, right? So multitude of technologies in there, right? And there has been early works in this space starting in 2013, where a framework called TARDIS was introduced, and this was about intelligent virtual agents for social coaching, right, in job interviews. So how they sort of came up with the architecture was to basically study human interaction, a coach who's coaching, say, a candidate, and then you have all these analysis in terms of body language and so on, which was then sort of translated into a system, right? A virtual agent, right? Which is trying to mimic, say, a coach, right? In some sense. And another very, what do you say, seminal work in this space is what is called SimSensei, and the analysis, the multimodal analysis, was called Multisense, right? And here you have a virtual agent which is having a conversation with a person who seems to be depressed, right? And given there is a rich literature on depression and so on, in this work, they analyze the user in terms of their body language, leaning forward, backward, gaze, smile, and so on, right? Speech as well, right? And then, I mean, the agent was programmed to sort of elicit a response from the user, right? And it was a fairly limited conversation, but this was sort of a really a full-blown system which was built using multiple groups at ICT University of South California, right? And this was another seminal work, right? And here you can sort of see the three parts in action, right? The analysis, what the agent speaks, and then how the agent gestures subsequently, right? And these are the three components that we are interested in, right? And let's go to the first component, which is multimodal analysis, right? And as we said, the primary goal of this will be to do some sort of fusion, right? Or for that matter, just how do you represent speech? How do you represent visual cues and so on, right? And there could be multiple levels of representation. Maybe there is a representation at a sensing layer, right, which is probably the raw values of, say, head rotation or the head pose information, or maybe at a higher level in terms of attention, in terms of, say, affective state and so on, right? So, and this paper, this work introduced what is called a perception markup language, which sort of helps these two units communicate, right? Maybe the dialogue and say the multimodal analysis unit, right? And there is a representation at different levels, right? At a low level sensing level, as well as at a behavior level and a functional level, right? And I mean, in terms of fusion, which is, say, an important aspect of this analysis, right? There exists a body of work, and I think this is a good summary in terms of multimodal affect recognition, which basically acknowledges that affect can be measured not just using visual and audio, but also physiological cues. And then there is fusion to be done either at a feature level or a decision level. And one could build these models both, I mean, you can build those models with, say, fairly controlled data set, maybe like a lab data sets, or in the wild data sets. And also sometimes these could be acted data sets or spontaneous data sets. And depending on what you use, maybe the application that you can envision or develop will depend on this, right? And another, what do you say, work that has sort of clearly articulated the role of multimodal machine learning is this paper by Louis Philippe Morency and others. And here they talk about various challenges, right, in terms of representation, say, for example, language cues versus, say, signals, speech, or vision. Alignment issues, right? Different signals have different frame rates and so on. There is the issue of fusion. How do you exploit complementarity between the cues, right? And also translation, when you go from one modality to another, right? Issues there and so on, because they talk about different types of applications, say multimedia retrieval, event detection, emotion and affect, and so on. So, so that was about analysis, right? And the clear challenges in the analysis is some of these, right? And apart from this, the challenges are to do with how do you develop a model which will work in the wild, and also what do you say, take care of subtle, spontaneous emotions and reactions and so on, right? So in terms of robustness, right, that would be the key challenge. Now let's move on to multimodal dialogue, right, which is, say, the second part of the puzzle, right? And in terms of what could be the goals that the dialogue manager attempts to do, right? In terms of, say, having a conversation, right, it has to update the dialogue context based on what it interprets about the user, right? So that's one task. Also, it can provide what is called context-dependent expectations, right? It can serve as priors while you interpret behavior. It also has to interface with, say, for example, some sort of knowledge base that you have, database, planner, or whatever, right? In order to coordinate the dialogue and non-dialogue behavior, non-verbal behavior, and so on, right? And then finally, it has to come up with what content to express, right? And when to express. So, so here it could be just pure text, right? Or it could be even speech and the associated, let's say, state that you could sort of be in while you express, right? And of course, there are several challenges with regard to say creating a dialogue manager, right? One of the challenge is in terms of what sort of technology one uses, right? So in terms of technology, right, you could use what is task oriented dialogue, right, where you have a very specific task. For example, you're trying to book a flight between one place to another, right? And based on what the user speaks, you understand it, maybe infer the intent of the user, right? Maybe he or she is saying about the destination that they want to reach, right? And within the state tracker that you have, you probably have certain slots to fill, right? And you also have some knowledge base access that you have, right? And then depending on that, you generate, let's say, text, right? And that is how a task-oriented dialogue is completed, right? An alternative to this is what is called a fully data-driven paradigm, where you have maybe a statistical model, say a neural network, right, to basically generate text, right, generate language, and people are aware of, for example, transformer models and so on, right? And you could probably condition the transformer model based on what is, say, the input text, or maybe the dialogue state or whatever, right? And it will still be a challenge to hook up any database and this statistical model, right? And a much more bigger challenge is how do you even complete a task, right? So while these are quite fancy in terms of what you could do with neural networks and so on, when it comes to actually completing a task, right? these methods still score, right? And maybe you could sort of build a companion type of model with a fully data driven approach, right? But to steer the conversation to task completion is still an open challenge, right? And and now let's move on to synthesis, right? Which is probably the last component here, right? Uh, and what are things involved here, right? And early work in this space was what is called a beat um, toolkit, right? So how does that work? You have a sentence, an utterance like this. It's some kind of a virtual actor. So that is the utterance, right? And maybe you have an animation object or an avatar which is speaking this, right? And what happens underneath, right? So you probably do some sort of parsing, right? And find out what each word is like. Is it an object or an action word, and so on, right? And then you have some sort of rules, right? You have rules which attach to each other word, right? For example, these two are in a gaze away position, eyebrow, right? Gesture, iconic eyebrows, and so on. Okay, so and this can be finally translated into in terms of what needs to be done, right, at different points in time, right? So here you see when a particular word is being spoken, what sort of tone and what sort of gaze needs to be expressed, right? And then this could be later translated into absolute time and so on, right? So this was an early work in 2004, which sort of proposed and posed this problem of synthesis, nonverbal behavior synthesis, which go along with, say, a particular sentence. And later, this was further extended, and people started to move away from just purely rules to models which are machine learning based, right? And a work in 2006 by Stacy Marcella's group. So they basically, assigned a word in terms of what communicative function it does, right? Interjection, negation, affirmation, and so on, right? And based on this, they also decided what nonverbal behavior goes well with these words, right? Head nod, shake, or whatever, right? And later, Marcella's group further extended this, and they have been pursuing this area of research for some time, along with Catherine Pelashud, who is also a researcher who has pursued nonverbal behavior synthesis for long. So what their work did was, instead of let's say looking at only word as a unit, they proposed that let there be a ideation unit, right? It's probably longer than words, right? And within these ideation units, you probably have, say, different gestures that are ongoing, right? And even within that, you have a preparation phase, a pre-stroke, hold phase, stroke phase, and so on. Because if you try to if you ignore this and generate gestures, what could happen is look very robotic, right? There's smoothness between gestures and so on, right? So they try to bring in smoothness, right? And this is still a work where just the surface text or what is being spoken is used to generate nonverbal behavior. Later, it was also extended, right? It was also extended to not just consider the text, but also acoustic cues, which basically take care of how the words are spoken, right? Along with what words are, right? And then you derive what is called communication function. And then based on that, behavior is mapped and expressed, right? And Stacy Marcella's group even very recently have proposed extensions and improvements over their initial architecture, right? So this is about what do you say? How do you generate smooth gestures that go along with a piece of text or how it is being spoken, right? And another line of work that has parallelly happened is the work on how do you build avatars which are realistic, right? So this is one.
Hello. I'm Sam, your guide to soul machines. What's your name?
Right, so these are realistic avatars.
Okay. Let's try that again.
And here you can see you're starting to have avatars which look more and more like humans, and the expectation is their behavior will also be like humans, right? In terms of how they speak and what they tell and so on, right? And apart from what do you say, face, in the future you should also see that the agents will be able to gesture, right? So if you remember, the Simpsons I work had gestures already, right? But here you have ultra realistic avatars with which we can probably communicate and probably also have gestures in there, right? So that is sort of the future challenges here, right? So that has been, let's say, an overview of conversational AI, particularly multimodal conversational AI. And now we will move on to sort of an offshoot of this discussion, right, where we present our own group's work, and in particularly two parts, right? One is on interviewing, right, agents that can interview, and also conversational AI for accessibility, right? In particular, sign language, right? So let's start with the first one. And so this was a work of Pooja Rao, an MS student, where she built an interviewing agent, which is not just what do you say, just ask questions or whatever, this interviewing agent, but can also ask a follow-up question, right? So you have the interviewer and then the interviewee, and then these are the typical parts of this conversational agent. But here, she built a follow-up question generator, right? And for that, she created a training data where you have these three triples, right? Interviewer, question, candidate response, and follow-up question. And she learned a model, and then let's say came up with a follow-up question generation, right? And for that, there was a language modeling loss as well as a next sentence classification loss, right? And a typical, let's say, the way it is trained looks like this, right? In terms of what all goes as input, right? Which is basically all three, the interviewer question, the candidate response, as well as the follow-up question, right? And here are some sample outputs. As you can see, for example, if the question was, how would you be an asset to this organization? And the candidate response looks like this, sort of a generated follow-up was looking like this. How would you handle criticism, right? Because he talks about criticism. And the human generated criticism looks like this, right? And of course, it won't be similar, or there will be differences. Maybe human generated follow-up would be better, right? But then here our goal was to sort of have the possibility of generating follow-up, right? And this sort of relates to a line of work, which is basically to make agents reactive, right? So they have to react to what the candidate speaks. It's not just ask question, get a response, and record it, right? You want to react to what the candidate spoke, right? And in an ideal world, you not just want to react to react to only what they speak, but maybe you want to also react to how they speak, right? And this was another work that we did, funded by Accenture Labs, where instead of instead of the usual loss functions that we had, we also had an affective state prediction, right? So suppose if the user's state is this, what should be the follow-up text state as well, right? Affective state as well, right? And for that, we used a particular data set which had this, I mean, pairs of sentences, which not just had the sentence, but also the affective state, right? And from that, we could learn a model and use that affective state. I mean, make sure that our follow-up also subscribes to that, what do you say, affective state, which is sort of expected, right? So this was, I mean, as you can see, these two works belong to the category of multimodal dialogue, which is neural network based, right? They use transformers and so on, and maybe a more task oriented application would probably use the other approach, right, where you have slot filling, intent, and slot filling, and so on, right? So this is a generative model. And we also have been working on an interviewing platform. So here you see a candidate who's, say, appearing for UPSC interviews, and he's being interviewed by a panel, right, where you have multiple interviewers, right? And we integrated our work on follow-up question generation in this paradigm, right, where say one of the panel members ask a question to the interviewee, and based on his response, there would be a follow-up question, right? So here's the platform, right? And
hi, and welcome to this demo of
the sheet, right, where a candidate can sort of log in, and it is developed by the Multimodal Perception Lab here at IIIT.
Soumya Margadashi. The targeted and also offers a complete mock interview, which is a simulation of how a real interview would be conducted. When a mock interview scene is loaded, notice that it is a complete 3D scene, and candidates can navigate around to get the feel of how a real interview experience would be. They can enter into the building and wait in the lobby, and when they're ready, they can choose to click and proceed towards the interview room. When the interview scene is loaded, there are a few instructions for the candidates, and the same also appear at the bottom during the course of the interview. The important part is that the candidate must greet the panel on entry, and only then also recorded later. So once the candidate is ready, hi ma'am, good afternoon sirs.
Please, sit down. Who is your inspiration as a civil servant? Why?
There are multiple civil servants who are an inspiration because of the...
So here you can see the candidate is responding, and after he responds, there will be
Dr. C.S. Kedar is one of them, who, as part of the system, revolutionized some of the medical implementations.
Do you think active politics should be an option for today's youth?
And based on the candidate's response, the follow-up question appears, right? And in terms of, if you think about this application, right? So on one hand, we want to bring in a bit of realism in terms of based on the candidate response, you get a follow-up question. So that is one. Also, we would like to give an immersive experience for the candidate, right? Because going to Delhi and getting mock interviews there may not be an option for several aspiring candidates, right? Maybe they are in a village or in a town. Whereas now with this tool that we have, right, which we have developed here at IIIT and collaborated with an academy called India for IAS Academy, you have the possibility of taking interviews at the comfort of your home, but at the same time, you have a sort of an almost immersive experience, right? And that gives you a good training when you actually go for interviews, right? And people who have attempted these interviews on this platform have really sort of given us a very positive feedback, saying this is really good, right? In terms of their training, having multiple interviews practiced on this platform helps them feel better, right?
Very different sides of the coin. While politics is
right. So that was about interviewing agents, right? And interviewing agent could be just one agent, or it could be multiple agents which are interviewing a candidate, and the application was UPSC context, right? Now we'll also talk about another work, which is conversational agents for accessibility, particularly hearing impaired. And this work was funded by Emphasis Cognitive Computing Center of Excellence. Okay, and here what we did, we attempted what is called the synthesis problem, Indian Sign Language synthesis, right? Compared to recognition, where given a text, you have to recognize what signs are being, given a video, you have to recognize what signs are being done. So video to text, right? Whereas that is a recognition problem. Synthesis problem is given a piece of text in English, right? How do you convert into, say, avatar videos or human signing videos? That's the challenge, right? And where it could be useful, say, for example, maybe a hearing impaired person is talking to a person who speaks English, right? So now how do you sort of help these two people communicate, right? So first, what we did in our first line of work, we with collaboration with Friends for Inclusion, we came up with a list of say top important words, right? 1,300 words, and we actually designed gesture animations, right, by graphics designers. But this is not a scalable approach because your vocabulary could be of the order of 10,000s, right? Not thousands. So we also needed a way to do it automatically, right? So what do we mean by that? We have signing videos done by multiple signers, right? And we want to convert these videos to the same avatar, right? And how do we do it automatically, right? That's the challenge. And we want to do it at an image level, at a video level, right? And for this, our approach basically involved, running, say, a joint estimation detector on say a video or on an image or on an avatar image, for example, right? And doing what is called a lifting from 2D to 3D and be able to control an avatar, right? For this, because we had these graphics designer created videos, right? We do have this paired information that is available in the training data, right? And thanks to this, now given given a video like this, we will be able to analyze it in 2D, transform it to 3D, and then be able to render it on a avatar, right? And this will help us to, say, convert one word that we have in a video form to a avatar form, right? Like this, we could probably do this transformation for 10,000 words, right? Instead of just 1,000, now you can do it for 10,000, right? So that is the problem we attempted and solved. And in terms of output, you can see our work that the hands are pretty well represented compared to, say, some other outputs and so on. Okay, so this was our work at the image level, which we've tried to extend it to a video level, which involves temporal smoothing and few other challenges, right? And when we were doing this work, we also got a feedback from, say, the hearing impaired users that I mean, having an avatar form compared to an avatar form, maybe a human form would be even better, right, for the output. So we also started to look at GAN-based transfer, right, where you have a signer who is doing this sign, right, and you have, say, this person, Sham, who's an MS student, his image is available, right? And now you can convert this. So you can do what is a translation, right? You can make Sham do the same activity as this, right? And this is also called as a deep fake in some contexts, right? And this is a good application of deep fake, right? There are possibly bad applications. So here is a good application where we can convert multiple signers videos to Sham doing it, right? So now if you want 10,000 videos using this technology, you can have Sham doing all the signs, right? And tomorrow, if you have to generate a sentence output, you will have Sham doing the whole thing, right? Instead of, say, multiple signers coming in and doing it, right? So this also involved, what do you say, a deep learn model and a generative output, right? And this work was also is also published, right, in ICVGIP. Okay, so these are some of the interesting works that are happening in the lab. And as you can see, I mean, just like you have sign language being generated, right? You could also have Sham talk, right? You can have Sham talk a new sentence that you want him to talk, right? So you can use the same ideas and bring in maybe lip sync instead of just hand gesture, right? So that is also an interesting line of work that uses GAN as output, right? So here is the output from one of our videos, and that's probably all that we wanted to share today. And thank you for your time.